So we've seen that we can still end up with anomalies in second normal form, which means we aren't done yet. Instead, we want to try to get to third normal form, which will address some of these. So in order to get to third normal form, we want to introduce a new type of dependency, functional dependency, and that's a transitive dependency. And as you might be familiar with from other transitive dependencies you've learned, like inequalities where if A is less than B and B is less than C, then A is less than C. Same sort of a thing here, except it has to do with functional dependencies. So remember that the syntax for functional dependency says that on the left-hand side is a set of the attributes that make up a relation, and the name for that left-hand side is the determinant, and it determines the values of some set of attributes on the right-hand side of that functional dependency. So we can say if A determines B and B determines C, then transitively A determines C. You recall that the example we were looking at had this item relation in it, and there was an item number, a description for that item, a distributor number, and a warehouse phone. Kind of an odd relation, but of course we're doing this intentionally to be able to illustrate the use of improving the form of the data by upping its normal form. We can intuit the functional dependencies here by taking a look at these fields. We can say that the item number functionally determines the distributor number, right? Because the distributor, an item is going to be distributed by a particular distributor. So if we have the item number, we can go look up the distributor number. And similarly, the distributed number is going to determine the warehouse phone. Again, we assumed previously that there's only one warehouse per distributor, which is maybe a unnecessary simplification or unrealistic simplification, but it's what we have here. So if we know the distributor number, we can look up the warehouse phone for that distributor. Now you can see that because item determines distributor number and distributor number determines warehouse phone, that we can say that the transitive property here of functional dependencies allows us to say that the item number functionally determines the warehouse phone, which is kind of counterintuitive, right? Why should an item number have anything to do with the phone number of the warehouse? And in this case, that is kind of an underlying issue lurking in the relation or the definition of this relation that gives rise to some of the anomalies that we just talked about. So the suggestion here that we've got these two functional dependencies suggests that we really have kind of two relations going on inside of this top-level item relation. And that's true in this case. But I want to kind of go a little bit deeper into this. The fact that it appears that we have multiple relations with these determinants as the keys isn't really enough to infer that we have a transitive dependency that's present. So let's try to take a look at what the real issue here. And I'm going to take another example here that tries to make this more manifest. So here's a new relation. It's called item. And it's got an item number, probably a key of some kind, that's assigned by the database, for example, the synthetic primary key. And then associated with that item is a UPC code, or a universal product code, right? This would be sort of a unique identifier for that particular product that's maybe a universal thing that other distributors might also use for that part number. And then a distributor number and a price for that item. Now, if you think about the attributes of this relation, we can see that we have two functional dependencies. First of all, the item number itself should allow us to figure out the UPC, because that's going to be associated with a specific item. The distributor number, assuming that we have one distributor per item, and then the price of that item that we're charging for it. But we can also see that the UPC code can serve the same purpose because it's unique to a particular item. So basically just kind of switching these two attributes around, we can say that we have a second functional dependence where the UPC determines the item number as well as the distribution or the distributor number and the price. Now, there's no transitive dependency here, right? Because all of the determinants on the left-hand side of these two functional dependents are candidate keys. For a transitive dependency, we have to have a determinant that is not a candidate key, okay? So the very fact that we have multiple functional dependencies here with different determinants, as we also have in the previous example, isn't sufficient for us to conclude necessarily that we have a transitive dependency, right? Because you can't find the same kind of a relationship where we have A going to B, B going to C, and then A ultimately determining C in a transitive way. We do have these two dependencies, but they're not transitive. And in order for there to be a transitive dependency, we have to have a determinant, a left-hand side, that is not a candidate key. So another way of thinking about that, and we'll see this in the fourth part of this series of talks, is that functional dependencies have to be among non-prime attributes. In other words, and if you think about kind of what that means, right, a non-prime attribute is one that doesn't participate in any candidate key. In this case, these two functional dependencies don't satisfy that criterion because both of the left-hand sides of those functional dependencies are candidate keys for this relation. We can know that that's true because the item number is uniquely assigned by the database and that the UPC number is uniquely assigned by some larger governing retail body kind of a thing. As I suggested, we're going to flesh this out a little bit more in the next talk in this series about how to use functional dependencies to determine how to get from one normal form to the next higher normal form. Then the definition for third normal form is similar to the second normal form definition. We have to be in second normal form to get to third. And oftentimes we sort of make a jump from first to third as a part of that process after you get good at doing this normalization process, or even when you're just designing a database right from the get-go. Because you're going to have some experience with this, you might actually just cook up third normal form tables for the most part when you're just working on an initial design. But again, we want to know all of the details under the hood so that we can go back and verify that, yes, in fact, this data model really is in some level of normalization. Often we're trying to get to third normal form. But in order to be in third normal form, we have to already be in second normal form, or we need to be able to go back and say, yes, in fact, this thing we think is in third normal form is also in second normal form. And the key thing here in second normal form is we have no transitive dependencies. And that kind of silly mnemonic about the key, the whole key, and nothing but the key, the nothing but the key part is what's important here. If we go back and think about this definition, all of the determinants are candidate keys, right? If we have other determinants that are not candidate keys, which violate that nothing but the key thing, then we have a possibility of transitive dependencies. So that's just a simple way to kind of remember what we're after when we're going to third normal form. And then let's return to this example that we were looking at before. So we've got this item relation. It's got an item number that's identified here as our primary key, a description, distributor number, and warehouse phone. And we had already identified functional dependencies where the item number determines the distributor number and the distributor number determines the warehouse phone. And both distributor number and warehouse phone are non-prime attributes, right? So we have a functional dependency involving non-prime attributes, and we have this A goes to B and B goes to C relationship. So we do have a transitive dependency that we need to pull apart. And we can do that, again, by using the functional dependencies as a hint for how to move forward. So the item number in the new revised item relation is now going to point or refer to the description of that particular item and the single distributor of that particular item. And we'll have a new relation that I've called distributor here that takes the distributor number and maps it to the warehouse phone. So now both of these relations are still in play, right? Except now the second one here isn't any longer dependent on a non-prime attribute, because in the new distributor relation, the distributor number can be identified as the primary key for that relationship. So now we no longer have this situation where we have a candidate key issue. Notice also that we can still, and this is true when we're moving from first to second or from second to third normal form, we can still get back the same kind of information, the same data that we could get from our original first or second normal form versions of the relation. Although we're not talking specifically about database joins and whatnot in this context, it's clear that we can actually restore the information that's encoded in this denormalized form of the item relation by doing joins, right? Because we have, in particular in this case, we have the distributor number, which you could see if you map this into an actual database, you can kind of see that this forms the role or takes the role of a foreign key that refers to that primary key, right? So we can reconstruct the original relation by doing joins. but we've now relieved ourselves of this burdensome set of anomalies, the insert, update, and modify, or insert, update, and delete anomalies that we've been seeing before, because we've now moved into third normal form with the relations.